Welcome to Tech Hook, a channel designed to pique your interest and provide you with the most in-depth information on technology, space travel, and more. If you're new to the channel, don't forget to hit the subscribe button. We'll be scouring our galaxy in today's video in a quest for the biggest star. We'll also look at how these stars are really classified by astronomers, among other things. Are you prepared to learn more? Let's start. Nuclear fusion is a mechanism that stars like our sun use to produce heat and light. If you're interested in learning a little bit more, you can always search up some of our previous videos where we've discussed topics such as why is space black and when will the sun die. However, the reason we are here today is to know if there is actually a star larger and brighter than our sun in this galaxy. So, let's begin. Though the precise number of stars in our galaxy is unknown, astronomers and scientists have established that our sun is not the lone star in the universe. In our Milky Way galaxy alone, there may be over 100 billion stars, each with a unique color, temperature, size, composition, and brightness. So, how are stars classified by astronomers and scientists? Ancient observers from all around the world thought that clusters of stars resembled humans or animals as they gazed up at the night sky. Today, however, we refer to such star clusters as constellations. As time went on, astronomers learned how to use spectrographs to classify these stars into groupings. They were able to ascertain the elements present in stars thanks to the use of the equipment. In essence, a spectrograph divides light into its many colors and creates a picture of the resultant spectrum. In this manner, a star's brightness may be calculated based on its size and temperature. Additionally, it may establish data like how brilliant a star appears to be from Earth and how bright the star truly is. A fun fact: did you know that the volume of a star may be determined by its brightness? The star's brightness is measured in two ways: apparent brightness and absolute brightness. Absolute brightness is the brightness of a star or any celestial object, as it would be seen from a standard distance, as opposed to apparent brightness, which is the brightness as seen from Earth. Then astronomers use electronic equipment to calculate the star's mass and volume, as well as its distance in kilometers. This approach gives near to precise information, even if it isn't always exact and precise. This information might be useful for both astronomers and scientists. Here's the fun part. Astronomers have discovered a single star among the billions of stars in our galaxy that is so big and large that its volume is approximately 5 billion times larger than that of the sun. Say hello to Uys-Kuddy. So now that you know what the galaxy's biggest star is called, let's get to know more about it. It would be fun to know that since its discovery, the Uys-Kuddy versus Sun has been a hot topic for debate that has actually dominated recent years. The fact that this star was so large and massive actually came as a shock when it was first identified. This is why scientists have actually given their best efforts to search for answers for why the star was so big and what could have contributed to its mass. All you need to know about the Uys-Kuddy. Well, now that we know that the star is big, how big is it? The Uys-Kuddy has a radius that is around 1700 times greater than the radius of the sun. It is also 30 times heavier than our sun. If you put it in diagrammatic form, you could consider that a sphere the size of Uys-Kuddy could hold a volume of about 5 billion suns. This means that if the sun and the Uys-Kuddy were actually kept beside one another, the sun would appear like a speck of dust. So, what category does this star fall into? It could come as no surprise that Uys-Kuddy is actually a hypergiant star. A hypergiant star comes right before the supergiant, which comes before a giant star. It was discovered by German astronomers who were working at the Bonn Observatory. These German astronomers initially cataloged the star in 1860 while completing a survey for the Bonner Durchmusterung Astrometric Star Catalog. They originally named the star BD 125055 and later gave it the name Uys-Kuddy. but they noticed something different. During a second study observation, the scientists noted a minor alteration in the star's brightness, which led the scientists to believe that the UI Scuti was actually a variable star. Now, a variable star won't usually have defined data on its size, its dimension, or its chemical composition, since it's constantly changing. In other words, it is variable. Years after the discovery in 2012, scientists were able to calculate the star's true size after a survey with a Very Large Telescope, or VLT, in the Atacama Desert in Chile. The survey was carried out so that the three stars that lay in the region of the sky near the galactic center would determine the mass and volume of the UI Scuti. The other two stars were AH Scorpii and KW Sagittarii, also classified as red supergiants, that are among the largest stars known and have luminosities over 100,000 times that of the Sun. After the survey, UI Scuti replaced VY Canis Majoris, NML Cygni, and Betelgeuse as the biggest stars currently known, taking the title from all of them. So, where is the UI Scuti located in our galaxy? Scientists have found that the UI Scuti is likely a star rich in metals, given its position far inside the Milky Way. The star is said to be located in the northeast direction of the Eagle Nebula and a few degrees north of the A-type star Gamma Scuti. UI Scuti is extremely bright, yet because of its distance and placement in the Cygnus Rift zone of avoidance, it is only 9th magnitude as seen from Earth. So, can the UI Scuti be seen from Earth? Well, the UI Scuti can actually be seen from Earth, since this star is located in the Milky Way galaxy, and it is at a distance of about 5,219 light-years from the Earth. If you look through those scientific telescopes, it can be seen. It's also amusing that the distance between the two is not more than 5,100 light-years away. That's even closer than Alpha Centauri, which is also a big star but not as big as the UI Scuti. Has this sparked your interest in knowing what it would be like if the Earth has revolved around the Sun that big? Well, if we hypothetically picture it, our Earth would probably take about 10,000 years to complete just one revolution, which means a year. And if we talk about seasons, that's almost like 2,500 years per season. Now, you wouldn't want that. And now, what is the future of the UI Scuti? Why is it so big? According to evolution models, the UI Scuti is now fusing hydrogen in a shell surrounding the core and has already started fusing helium. What does this mean though? This just indicates that the UI Scuti has lived 90% of its life. This indicates that there is just 10% remaining. If you had to put this percentage into years, it would probably add up to only a few million years. Another reason why the star is so huge is that it's almost on the verge of dying. The star will start producing iron once it starts fusing helium and hydrogen in its core, thus balancing the harmony between gravity and radiation to eventually cause a supernova. I hope you've learned that the next time you gaze at our sun, simply consider all the amazing things the universe has to offer and consider the possibility that there may be a greater star out there that we haven't yet found. Do you believe that the supernova will still be visible in 5 billion years? Well, time will tell. If you liked this video, do hit the like and share buttons. Thank you for taking the time to watch this video, and I hope to see you at the next one.